molecules, right? No. What's the other name? Biomolecules. All right, so now what we want to do is talk about what makes up large versus small molecules. So I got all these different little things to play with. So take a look at this. And no, whenever I bring these up, you're like, oh, please, let me play with it. All right, and then same idea with this. Okay, is this all the same thing? Okay, this is a bunch of them, and this would be one. Okay, what word do we use for in science? And usually Greek and Latin is our base for one. Mono, uni, right? But so in this case, mono. Okay, and then so this is a whole bunch, or as in many, what we use for that? Poly. So we got. So here's the thing: we're going to start generic, and then we're going to get specific to the 4 biomolecules. So this would be a monomer, and this would be a polymer. A polymer is basically this. Here I am. I'm making a polymer. Amazing. I'm doing polymerization. Polymerization, I should have said. All right. I've made a polymer. Okay. So, okay. So, is there any difference between this versus this? Don't tell me color change, just the size. So it's the same principle of what I was just demonstrating here, just another visual. Okay, so monomer, polymer. Okay, are we following? So let's look at this. We'll get to the examples in a second. So large molecules are called polymers. They're made up of smaller building blocks called monomers. Now I should tell you in my notes, a lot of times I'll say building blocks, I'll say monomers, I'll also use the word subunit. So once you write subunit in there, in parentheses around monomer. Okay. So here's the deal. We're going to expect you to know generically what a polymer is and a monomer, but then we're going to expect you to know for the big 4 molecules. I'll have it up there for you to copy down in a second. They're carbohydrates, lipids, proteins, nucleic acids. So imagine this, and now look at my models. This is what this little square looks like. Right? This when I was using this is just generic. Now we're going to get into a specific example. Okay? Can you go through and close that door? Okay, so now, yes. So imagine, now I'm going to stick these together next class period because we're going to need to know the name of making a molecule and also breaking apart a molecule. All right? So each one of these squares is representative of something like this. This is an accurate scale of a molecule called glucose. So we actually name the molecules by their polymer name. So carbohydrates, proteins, nucleic acids. All right? There's one other called lipids. And I'll probably go in that order, carbs, lipids. All right, so imagine this stuck together. This is glucose. Stick another glucose. And then another one. So if the monomer name for carbohydrates would be called a monosaccharide. So if I stick 2 of these together, what do I call that? A polysaccharide, but we have a special name when 2 of them are stuck together in carbohydrates, and we call that a disaccharide. Okay? So what you're going to see is we have the generic name and then specific examples. Like we don't really call dipeptide, we'll just call it poly. Right? So here's a glucose, another glucose, another glucose, another glucose, another glucose. So if we have a whole bunch of them, what would that be called? If this is the monomer and it's called a monosaccharide, the polymer name, what would that be? We have many, what? Many saccharides. Polysaccharide, correct. Okay? Now, here's another molecule we're going to learn. Now, here's the deal. I keep saying using this as the example, but this specifically looks like this. This is called an amino acid. And then I take another amino acid and I attach it. And then I take another and I attach it and attach it and attach it. The bond between them is called a peptide bond. So peptide, peptide. If I have a whole bunch of these amino acids stuck together now this represents amino acid, and it's really many peptides. What's another way of saying many peptides? Polypeptides. And that's actually the polymer name for proteins is called a polypeptide. When it folds and becomes a actual functional protein, that's actually the point where we'll call it a protein. So it could be like a fibrous one, like, you know, the fibers that make up muscle. Of course, if this was accurate, you need a lot more fibers to show these guns here. But all right, so let's think about where we're going with this. You have a handout, or you're going to get one, I should say. It looks like this. The chart gives you name of compound, name of compound, elements, subunits and polymers, and then examples. So if you follow the notes we're going to give you, this will be very easy. Now the hard part for it is students don't like to read. So we're going to say do the chart first and then fill in this part. You're going to get to start this in class. All right? So what are the big 4 biomolecules? Here they are. Carbohydrates, lipids, proteins, nucleic acids. So what's going to happen next is I'm going to have you guys copy this down, and then I'm going to give you a slide for this slot one, this one, this one, and this one. All right, so I'm going to stop filming for a second. I want to get those slides here. So don't copy this.